Hi everyone, and welcome back to another episode of Dr. Kyle Explains, your YouTube channel where we go through GCSE science content quickly and easily. Today we're going to be going through the electrolysis of solutions. So without further ado, let's give the video a thumbs up and a like, tell everyone about it, subscribe to the channel, grab a pen, grab some paper, and let's go ahead and jump in. Okay, so quick recap then. How can ionic substances conduct electricity? Now, for this video, I would really recommend you watch my other video on how electrolysis works for molten solutions before you carry on. But just as a recap, electrolysis can happen when molten, so when melted, or dissolved. What happens? The ions are free to move, and so they can carry the charge. Okay, that's your quick recap. It is really important to understand how ionic substances conduct electricity, and that's when they're molten or dissolved. The ions are free to move, so can carry the charge. So specifically for today's video, it's when they are dissolved that we're going to be looking at. Now, the ionic equation for neutralization, just as a recap, hopefully we know this already, is H+, that's an acidic ion, plus minus OH, your hydroxide ion, and that can make H2O, and that is aqueous, and liquid. So just as those state symbols, dissolved in water for aqueous, dissolved in water for aqueous, and then obviously H2O is water, so that's a liquid. Now again, what's really important to remember this ionic equation for neutralization is a reversible reaction. So whenever you have a little bit of water, it means you have a little bit of hydrogen and a little bit of hydroxide ions present, and that's going to be really important for today's lesson. Okay, so electrolysis of solution rules. Now, these rules will not be asked as questions for your GCSE, but you do need to learn these off by heart and be able to apply them to questions. And hopefully you'll see as we go through some examples. So rule number 1, if a halide is present, then a halogen will form at the positive electrode. So for example, I've got my halide here, fluoride, and it will make fluorine. So any group 7 element, that's the halogens, if you have the ion of it, it makes an ide. So for example, chloride is the ion, the negative charged, and that will make chlorine. Bromide will make bromine, Br2. Next rule, if an 8 is present, then the oxygen will form at the positive electrode. And so sulfate, just down here, is SO4 minus 2. It's a charge, so that's an 8. That will make oxygen. If I give you another example, if I take phosphate, so that's PO4, so minus 3 charge, that one. The charges aren't particularly important. Phosphate, PO4, that will make oxygen. Now, they don't actually form that. This is just kind of a way to remember it. And so the way I always tell people is if it's got a lot of oxygen there, like that, it's going to form oxygen. Now, that is not the actual reason it forms oxygen. I will go over that later on in this video. But as a general rule to figure out what's going on, if an 8 is present, then oxygen will form. Okay, your last rule. If the metal ion is more reactive than the H+, then hydrogen will form at the negative electrode. So, i.e., if gold is present, gold is not particularly reactive. Think about the reactivity series. It's very low down the reactivity series. We use it for jewelry. Very, very unreactive metal. And so it's not more reactive than hydrogen. It will form gold. Sodium, or the sodium ion, is a very reactive metal. You put it in water, it fizzes, moves, dissolves really quickly. And so that's a very reactive metal. It will form hydrogen. Now remember, if you go through my videos on reactivity series, you'll see where kind of hydrogen and these metals lay, or if you just Google reactivity series, you'll see the metals kind of below hydrogen are things like gold, silver, copper, things like that. So anything above hydrogen, if it's more reactive than hydrogen, you will form hydrogen gas. Okay, so give you a quick go at using these rules then we'll go into a bit more explanation. So on this table, if you just draw out kind of these different compounds here and then write positive, negative, positive, negative, positive, negative, positive, negative, positive, negative, and then I want you to tell me what's forming at each. Now remember, it's really important to look at the state symbol to know whether you need to apply the rules or not. pause the video now and have a go. Okay, so sodium chloride, aqueous, so you need to use your rules. Sodium, metal ion always go positive, the non-metal always goes negative. You've got a chloride present, so chlorine will form, and sodium, really reactive metal, so you'll form hydrogen. Next one, sodium chloride, liquid, not an aqueous solution, so you don't need to use your rules. And so this one, again, will be chlorine forming, and then you will make sodium. And so hopefully you can see the difference, whether it is molten or if it's dissolved, you can make different products because it's in solution. Right, next one, sodium sulfate. So sodium, really, really reactive metal. And so what we're going to form hydrogen, sulfate. If an 8 is present, you form oxygen. Copper chloride, aqueous. So again, we need to use our rules. Copper, not a very reactive metal. And so we're going to form copper. Remember, your metals always form positive ions. Chloride, so chloride is present, so you're going to form chlorine. Well done if you got that right. Potassium bromide, liquid, so not a liquid, not dissolved in solution, I should be saying, and so therefore it's molten, and so therefore potassium is going to form at your negative, Br2 is going to form at your positive. Last one, potassium nitrate, aqueous, so an 8 is present, so we're going to form oxygen, and then potassium is there, so we're going to form hydrogen again, as potassium is a very reactive metal. Really well done if you got those right, and you followed that through. Okay, so why does this happen then? Let's just go into a little bit of explanation. So if we draw out our electrolysis tank, just here, and stick in our electrodes, positive, and negative just there, and then draw in some power. So hopefully we can see we've got our little solution here, we've got our electrolyte solution. So let's take the case of sodium sulfate, for example. So we've got Na2SO4, aqueous. So that goes into there, and so what we've now got sodium plus SO4 minus, just there. We've got H plus and we've got minus OH. Remember, because it's aqueous, so you've also got water present. Now remember, H plus minus OH goes to H2O. So whenever you've got water present, you've also got these ions floating around. And so just like last time, you've got a positive and negative. So the negative is attracted to the positive and the positive is attracted to the negative. So when it's an aqueous solution, you have other ions present. When it's just molten, all you will have is whatever you've melted. But because we've dissolved it in water, you've also got H plus and minus OH floating around. And so in the case here, what's going to happen? You've got your sodium ion that is more reactive than the hydrogen, and so therefore the hydrogen will move to the negative electrode, and you would physically see bubbles of hydrogen gas forming and being given off. And so what actually forms, the more reactive metal will stay in the solution. Now here you've got sulfate. What will happen here? Your hydroxide will move to the positive, and then something a little bit more interesting happens. So your hydroxide ion will now break down and it will form oxygen. This is where your oxygen's coming from, and water. And if we balance this equation, I think we need 4 of those. So then we put 2 there. And so we can see when the hydroxide moves there, you're breaking down your hydroxide ions and you are forming bubbles of oxygen. And so what you would then make in your solution is going to be your sodium sulfate solution. And so you're going to make hydrogen gas and you're going to make oxygen, and your solution of sodium sulfate would gradually get more and more concentrated over time. Really well done if you followed that through. Thank you very much for watching. Please do go through my other playlists for more GCSE science content. And remember, whenever you need help, Dr. Kyle explains.